All right, this video is going to talk about access control lists for IPv6 traffic on Cisco routers. First thing we want to know or should review is that these work just like IPv4 access control lists. We need to apply them to an interface and in a direction. So one of the things we're going to worry about doing is filtering outbound traffic for traffic going out of our network to only allow HTTP and HTTPS traffic. We can first test to make sure that all HTTP and HTTPS traffic is working by using our browser here on one of the PCs to connect to our web server. So that was HTTP that worked. HTTPS worked. And right now we're going to test ping as well, because ping is going to be our test case for something that will be getting dropped. So we're going to filter outbound traffic. We only want to let web traffic out. In the real world, we would probably want to allow DNS traffic out as well, but the server doesn't support DNS for IPv6, so we're not going to worry about DNS right now. So anyway, the first decision we need to make is where do we want to filter. Usually for outbound traffic, you apply the filters in one place. So router 0 at the edge here, we could filter to block all traffic going out. We could also put it on router 1 on this outside interface to filter, because that's the router that is controlling pretty much access to all your little smaller networks back here. You could put it on each of these routers. An access list on each router blocking the traffic, but then you have more than one place to update and manage the access list, which is not desirable. But if you drop the traffic out here, then now you're passing all these extra packets that you're going to end up dropping later on anyway. But most places just filter on the outside somewhere. So if I was going to filter this traffic in the outbound, I would probably either do it on router 0, FA00, or router 1, FA10. I'm going to do it on router 0, and I'm going to do it on FA00 to start with. So the first thing we need to do is construct an IPv6 access list. And IPv6 access lists are all named access lists. There are no numbers for IPv6. So we're going to create a named, and we're going to call it, outbound for simplicity's sake. We're going to add some entries into that list. So we want to permit TCP, and we're going to specify the source of the traffic. We could specify any as our source. We could also specify a specific host or a network range. I'm going to specify a network range because I specified you should use a particular subnet on all your hosts. So we're going to filter for traffic from that subnet 48. So basically that was the subnet I told you to use to create all your subnets from. So we're going to put that in there, and we're going to allow the traffic to any host, and we're going to specify the port for HTTP. We're also going to specify the port for SSL. So that was that. First, we're going to do a couple different things. First, we're going to put it on this outside interface. If we put it on this outside interface, we need to filter in the outbound direction. So we want to filter the traffic as it's leaving the router. So we need to go into FA00, and we need to apply that to the interface, and it's IPv6, and then traffic filter is how we apply it, and then we need to put the name of it. So I named it outbound, and then we need to put the direction, out. So now in theory, my access control list is applied to this interface in the outbound direction. So a couple different things we can do to test and verify it's working. One, we can actually try to ping, and now it's failing, destination host unreachable, which is good because we blocked that traffic. But we want to make sure the web page is still working. If I could remember what the IP is. All right, so it's still working on HTTP, and it's still working on HTTPS. So that's great, and that is what we wanted to do. But there's some other things I'm going to talk about. In some ways, access lists can be tricky. In the lab sheet for my class, I specified we want to put the the access list on router 0 FA1/0. So we're going to go take it off 0, 0. And then we're going to put it on, wait, that's not right, int FA10. And we're going to put it on FA10 in the inbound direction. And what's going to happen here is we're going to get some unexpected side effects. So we have to wait some number of seconds to get our unexpected side effects. But essentially, basically, we took this exact same access list and put it on this interface of the router in the inbound direction. So the unexpected side effect is we're only allowing TCP 80 and TCP 443 into that router. So now we have broken our routing protocol, which is bad. So if we go over here to router 4 now and we do show IPv6 route, we've lost our default gateway. See, we learned this default gateway from that router. Well, now we've lost that default gateway. So that was the bad unexpected side effect we had from changing that. If we go over here just to verify, if we go to try to ping, well, ping was broken anyway. If we try the browser, it's gonna fail now. It came back pretty quickly. If we wait long enough, it'll say request timed out. So that was bad. So a couple of different ways we can fix that. Well, we need to fix it on this router, and the way we can fix that is by adding some more entries to our access control list. So we want to do IPv6 access IPv6 access list outbound. And we need to allow some things to let the routing protocol traffic work. And what you need to add for that is going to depend on what your routing protocol is and what it uses to communicate. So we're going to go ahead and we're going to allow traffic. I have some lists here because I'm lazy. We're going to go ahead and we're going to allow some traffic. We're going to allow any IPv6 traffic from any host, from any source to the FF02::A multicast address. That multicast address is associated with EIGRP for IPv6, and that is the address that hosts the routers send their hello messages to. So we're going to add that. That was what I thought. That was what I thought we needed initially. So I added that, and it turns out when you add that, it seems like it might think about working. But it doesn't really work. And the reason it doesn't really work is because the router will send the hellos to the multicast address. So then any routers on that link can hear them. But then when it needs to send specific information, it uses unicast traffic for that. So if we look, what's going to happen is it's going to find a new adjacency, and then it's going to fail to do anything else because we're not allowing the unicast traffic. So if we go look at router 4, hopefully it will not have the default route. The default route is still showing up, which might be a simulator thing. But the routing protocol is still not fixed, even though that seems to be showing up. That's weird. Maybe it takes a while for it to time out. Yeah, it's still showing up, but I don't know why. It should not be. Even if it is showing up, it's not working. So we can't get out still. So that was a weird thing I saw. So then I went and added another list that basically said any traffic between these two routers, let that in. And the first time I added it in my testing, I used these FD01 addresses, and it still didn't work. So then I added the list using the link local addresses, because apparently they send traffic locally using the link local addresses. So we'll paste that in there. And now, in theory, my routing protocol should start functioning properly again. And I should be able to connect again. So now I can get out. So basically, I had you guys put the access list on this specific interface in order to break some things, so we could recognize the unexpected consequences of that. And part of my reading about why that wasn't working, I did find something interesting. So I'm going to do something else to demonstrate it. I didn't test this yet, so hopefully it works. So we're going to go into we're going to take the access list off. We're going to take it off. All right, so now there's no access list on that router. So everything should be working. I should be able to ping again because that's the thing I'm testing. I can ping again. Now we're going to build a similar access list and put it on a router 1 on this interface in the outbound direction. So we're going to create the access list. We're going to put the same stuff in there we had initially. TCP to any host EQ80. So we're going to let port 80 out. We're going to let port 443 out. That's all we're going to do. And then we're going to put it on 10 in the outbound direction. So now we've put it in a different place. We've put it on FA10 in the outbound direction, right? And before, when we were filtering between these two routers on this router on 10, we had issues with our routing protocol. If we filter on this router on 10 in the outbound direction, are we going to have similar issues with our routing protocol? Well, what we observed before was that we had an error message that came up on the router that said, lost adjacency or whatever it said, and then we couldn't connect. So right now ping should still be failed because our access list is not allowing ping. So that's failing. So our access list is applied. This should work. So that worked. So our access list is working properly. So that's weird, right? When we put it on this interface of router 0, it broke the routing protocol. But putting it on the outbound interface on router 1, it didn't break the routing protocol. And that works that way because according to the documentation, IPv6 access lists do not filter router-generated traffic if you apply the access list in the outbound direction. So what that means is if we have an access list on this router in the outbound direction, any traffic from the router will be allowed by default. So if this router is trying to ping something, the access list won't drop it. If it's trying to send the routing protocol updates, the access list won't drop it because that's the way they decided to make it work. On this router, in the inbound direction, the access list doesn't automatically let in that necessary traffic because it could be coming from any source that may or may not be trusted. So in the inbound direction, the router is much more picky and actually honors the access list. In the outbound direction, it lets anything that the router generates out without having to require you to put those entries in the access list. So that's just something I thought was a little interesting, a little different, how we can put the same access list in two different places, but end up with different results. I found that to be a little unintuitive. So that's the basics of IPv4 access control lists and how you apply them to filter traffic between subnets and whatnot. Yeah, that's really all I'm going to talk about for now.